In the world of technology, standardization is key. Just like USB-C allows you to connect a wide range of devices to your computer with a single port, the Model Context Protocol or MCP aims to do the same for AI applications. But what exactly is MCP and why is it so important? Let's dive in. By mid 2024, large language models or LLMs were incredibly powerful, capable of understanding and generating human like text. However, they had a significant limitation. They couldn't easily access real time data or interact with external tools like calculator, web searchers, or databases. Techniques like retrieval augmented generations or RAG, often built with frameworks like Langchain, tried to bridge this gap. But integrating tools with LLM was a cumbersome, as each LLM providers, whether OpenAI, Gemini, or others, required their own unique setup. This lack of standardization made it tough for developers to create seamless, tool-empowered AI applications. Enter the Model Context Protocol or MCP, developed by Anthropic and open sourced on 24 November 2024. MCP is an open protocol designed to standardize how AI applications, particularly LLMs, connect to external data sources and tools. Think of them as universal language that allows AI models to seamlessly interact with the worlds around them. Whether it's accessing your files, searching the web, or even ordering a pizza. Let's start with the core architecture of MCP. It follows a client-server model and has three important components. Hosts are AI applications like Claude Desktop or an AI-powered IDE that initiate connections. Clients reside inside hosts and maintain one-to-one connections with servers. MCP servers are lightweight programs that expose specific capabilities such as data source or tools through the standardized MCP protocol. Each host can connect to multiple servers, and each server can provide different types of resources or tools. This flexibility allows developers to mix and match capabilities as needed. MCP supports two main ways for clients and servers to communicate. stdio or standard input-output, which is ideal for local processes where the clients and server run on the same machine. HTTP with server sent event or SSE, and it is used for remote connections, providing real-time bidirectional communication between client and server. This dual support ensures MCP can be used in both local development environments and distributed systems. The connection between a client and a server follows a clear life cycle. In the initialization, the client sends an initialize request to the server specifying its version and capabilities. The server responds, and once both are ready, communication begins. The client and server exchange messages using JSON RPC 2.0, a standard for remote procedure calls over JSON. The connection can be closed gracefully or due to errors or disconnection via the close function. This structured approach ensures reliable and efficient communication. Now let's talk about what MCP provides to make LLMs more powerful. MCP introduces three key concepts: resources, tools, and prompts. Resources. These are data sources that provide context to the LLM. Think of them as files, databases, or any other form of data that the AI can access to generate more accurate and relevant responses. For example, a resource could be a local file on your computer or database containing project information. GET requests in the RESTful APIs are analogous to resources. Tools. These are functions or APIs that the LLM can call to perform specific actions. Unlike resources, tools enable the LLM to act as an agent. For instance, a tool might allow the LLM to search the web, perform calculations, or interact with external services like ordering a pizza through an API. Prompts are templated messages or workflows that servers can provide to clients. They are not directly fed to the LLM but can be used by users to guide the AI's behavior or provide additional context. For example, a prompt might be a predefined question template that help structure user input. In summary, the Model Context Protocol is a groundbreaking standard that connects AI models to the data and tools they need. By providing a universal protocol, MCP simplifies the development of AI applications, making it easier for developers to build sophisticated tool-empowered systems. The benefits are clear. As AI continues to evolve, protocols like MCP will play a crucial role in making AI more accessible, powerful, and integrated into our daily lives.